d square y by dx square minus 2 dy by dx plus y equal to 8x e power of x sin x. So this is the differential equation with the constant coefficient. Okay, but in the right hand side we have some different functions. Okay, first you convert it into standard form, that is in terms of capital D. So here capital D is always d by dx. Therefore if you first take y outside, remaining d by dx can be taken as capital D, and d square is d square by dx square. So the above differential equation is converted into d square minus 2d, take y outside, so e plus 1 into y equal to 8x e power of x into sin x. Okay, now this is the differential equation in standard form. Now to find the solution, first I want to find out the complementary function, and then we have to go find out the particular integral. For that I am going to write the auxiliary equation. So auxiliary equation is replacing d by m. So m square minus 2m plus 1 equal to 0. This 1 can be written as minus 1 into minus 1 plus 1, adding these two minus 2 here. So that it is m minus 1 into m minus 1 equal to 0. So m equal to 1 and m equal to 1. Both are equal values. So the complementary function is ax plus b into e power mx. So this is the formula if two values are equal. So the complementary function is finally ax plus b into e power m is 1, so 1 into x. So this is the complementary function. Okay, next I am going to find out the particular integral. So the particular integral pi is equal to 1 by d square minus 2d plus 1 into 8x e power of x into sin x. Okay, now I am going to treat e power ax into v, remaining term you treat it as v. So this is I am going to use type 5 model, e power ax into v. So first I am going to operate e. So the coefficient of x is 1, so d is replaced by d plus 1. But you see this is one of the special problem, because in this problem m values are equal. So this term can be written as 1 by d minus 1 the whole square, 8x e power of x into sin x. So e power ax, x coefficient is 1. So here I am going to replace d by d plus 1. So the term e can be taken as here. So along with the 8 also I am going to take. So 8 into e power of x take here. At the same time replace d by d plus 1 by e power ax, remaining term v. So replace d by d plus 1 here. So d plus 1 minus 1 the whole power 2, remaining term x into sin x. So plus minus 1 plus 1 cancel, so that it is 8 e power of x 1 by d square x into sin x. So that we want to integrate 2 times with respect to x for the function x into sin x. Okay, so next I am going to integrate 2 times with respect to x. First 1 by d I am going to apply. Actually 1 by d is integral, 1 by d square means 2 time integral. So this is 8 e power of x. So 8 into e power of x, 1 by d, another 1 by d you take it as integral x into sin x dx. Okay, this is integration by parts. So but you can use integration by parts, or otherwise you can use Bernoulli's method. What is Bernoulli's method? The Bernoulli's method can be simply, I give some example for Bernoulli's method. You see, for example, integral x square cos x dx. To apply Bernoulli's method, the rule is take algebraic term first, integrate the remaining term. Integration of cos x is sin x, alternatively plus or minus. So first plus, next minus, differentiate x square, it is 2x. Integrate the term, sin x integral is minus cos x, and next minus after that plus, differential 2x is 2, again you integral of minus cos x minus sin x, and then next you differentiate this 0, so this is over. So this is Bernoulli's method. So what is Bernoulli's method? Take the algebraic term first, integrate the remaining term, and alternatively plus or minus differential, integral, and so on till you are getting constant, because next term is 0. So this procedure is called Bernoulli's method. So for the integration by parts, Bernoulli's method is very easy. So here also I am going to apply Bernoulli's method. If possible, you can apply integration by parts also. Okay, so now but I am going to apply integration of Bernoulli's method only. Okay, so 8 into e power of x 1 by d. Here I am going to apply Bernoulli's method. What is Bernoulli's method? Take algebraic term first, integrate the remaining term, sin x integral is minus cos x, and alternatively plus or minus plus, next term minus, differential x differential is 1. Again you integrate, integration of minus cos x minus sin x. So next term will be 0 because 1 differential is 0. So Bernoulli's method over. Okay, so now I am going to simplify, then I am going to integrate, because again we are having 1 by d. 1 by d mean integral. So 8 into e power of x 1 by d into simplify minus x cos x minus of minus plus sin x. So now I want to integrate, but the first term is negative, so that I am going to take, conveniently I am going to take minus outside. So minus 8 into e power of x 1 by d is integral x cos x minus sin x into dx. There are two integral terms. Here I am going to apply Bernoulli's method, but here direct integral. So already we know the Bernoulli's method, so I am going to apply. So here minus 8 into e power of x. Here apply Bernoulli's method. What is Bernoulli's method? Take algebraic term first, integrate the remaining term, cos x integral sin x, and alternatively plus or minus plus, and then minus, differential of x is 1, integral of sin x is minus cos x, and next term is 0 because 1 differential is 0. So first integration Bernoulli's part is over. Next one minus integral of sin x minus cos x, so minus of minus plus cos x. So entire integral part over. This is particular integral. So that minus 8 into e power of x into x sin x minus minus plus cos x plus cos x plus 2 cos x. So that it is the particular integral. So particular integral is minus 8 into e power of x into x sin x plus 2 cos x. So this is particular integral. Now the solution. Solution is y is equal to CF plus PI. So y is equal to, what is CF? AX plus B into e power of x, and the particular integral is, this is minus 8 e power of x into x sin x plus 2 cos x. So this is the solution of the given differential equation.